Welcome to Sensorica. Sensorica is a network of people that are coming together from all over the world to create projects together. We see it as a new way of working together, using peer-to-peer protocols and using open source technology to be able to bring value to communities anywhere in the world. We're going to explore the photovoltaic characterization project. And so Tibby, can you share a bit about the project and how it came to Sensorica?
So the photovoltaic cell characterization project is about characterizing photovoltaic cells. Okay, so photovoltaic cell is a device that turns light energy into electrical energy. And scientists need a device to characterize these materials. Essentially, they need to orient these materials at different angles with respect to a lamp that mimics the sunlight, and to measure, as they change the orientation, how much energy they produce. So this is what Sensorica is building. This is the photovoltaic characterization project is about designing and building this instrument on which the photovoltaic cell sits, and it's oriented with respect to this lamp. So how this project came to Sensorica, actually Professor Joshua Pierce from Queen's University, he contacted us and he wanted us to develop this device. And now, why would a university call Sensorica, which is an open network? It's not really a company or it doesn't have a structure that is recognized. Well, because Sensorica is an open source network, and the value that Professor Pierce sees in Sensorica is to make a device, to make a scientific instrument that has a wider or greater social impact. Okay. So the university could design such device. Actually, they are paid to do that, and they have the skills, they have all the resources needed to do this job. What Sensorica does, on top of that, building a physical device, is to socialize the process.
What's that mean? What does socialize the device mean?
Well, socializing the process and socializing the device means that the innovation process, the way we do it, the way we design it, is done in an open way. So we invite everybody that has an interest in the technical aspects of the project or that has an interest in the technology to come to join us, okay, to develop. So we develop it as any other open source project develops, in an open and transparent way, and we invite everybody to participate. So Jim will explain how this thing is put together.
Sure, I can tell you a little bit of all the components that make up this scientific instrument that we're building. So basically, it's a laptop running some software, open source software that we're going to develop, which is controlling a motorized platform that rotates on two different axes to characterize the cells. A couple of things were requested by the professor. One be that we have a laptop running the software that's connected to a microcontroller board, that the actual device be as 3D printable as possible. Mm-hmm. So anybody can basically download the files and recreate the device. The microcontroller is a very easily available Arduino board used by hobbyists and professionals for prototyping all across the world, very easily available. We replaced the laptop because we thought a laptop was a little bit overkill. You don't need a whole laptop to actually power a motorized platform. We've replaced it with the Raspberry Pi, which is basically a whole computer system on a board, very, very inexpensive. So this drives a microcontroller. We have a 3D printable platform controlled by two stepper motors. And
that's how it's put together.
And that's how it's put together.
That's fantastic.
I was looking for something more, but it's simple as that. Of course, it takes a lot of time to develop because we've listed every single possible option, and we've come up with some brilliant ideas on how to actually design this device.
Mm-hmm. So once it's done, essentially, the device will have a community around it. The device will be very low cost to produce. It'll be open source. And it'll be a living thing. If somebody wants to make it, there will be a forum available where the person can get in contact with this community and ask technical questions, how to put it together, and so on.
So what are some of the applications for communities for this type of technology?
It's lab-based. It's a very it's a device that is limited to laboratory applications, to science and characterizations of this panel.
That's right.
But the design is made in such a way that it could fork and be remixed into something else.
Yeah,
Optimizing photovoltaic cells.
Or something else.
or something else. Actually, a couple of the principles that we're developing could be applied to other types of devices too. One of them is, because it's very similar to the gimbals that are used by the drone community
Right.
to stabilize cameras. It's a very, very similar device. It could even be a face tracking device for teleconferencing.
Right.
So it could be adapted. A lot of these things could be adapted, and we already have a couple of ideas that we'd like to try the designs for.
Well, one of the things that I've been excited to be able to witness is the level of creativity and potential within the open source process. So I just want to also thank all Sensoricans that have been working on this project, because it's been very exciting to see what happens when you bring creativity to life in this way. So I hope you've enjoyed our little exploration of the work that we do here at Sensorica. What we're doing is in service to a greater vision where we help each other, where we create things that are useful and can be used in communities anywhere in the world. So we're looking for your help. We're looking for your participation. We need people who would like to participate and build in our projects with us. And we're looking for communities that need to use what it is that we're creating. And we are looking for people who can help us to fund our development. It is all of us together that makes the difference. And so we invite you to be a part of it.